Welcome to the fascinating world of semiconductors. These tiny components are the backbone of modern technology, powering everything from smartphones to advanced computers. In this video, we'll embark on a journey to understand what semiconductors are, why they're so important, and how they've revolutionized our daily lives. As we move forward, you'll see how these small yet mighty materials have shaped the digital age, making possible the devices and systems we rely on every day. Let's begin by exploring the basic concept of semiconductors and their role in electronics. Semiconductor is a material that has electrical connectivity between that of a conductor and an insulator. This unique property allows it to control the flow of electricity, making it ideal for use in electronic circuits. Silicon is the most commonly used semiconductor material, but others like germanium and gallium arsenide are also important. The ability to manipulate electrical signals is what makes semiconductors the heart of modern electronics. Next, we'll look at how semiconductors are used in everyday devices. Semiconductors are everywhere around us. From the smartphone in your pocket to the car you drive, these components are essential for modern living. They enable the miniaturization of devices, making technology more powerful and accessible. Whether it's your television, washing machine, or even medical equipment, semiconductors are at the core, ensuring efficient operation and smart features. As we continue, let's see how the semiconductor industry has evolved over time. The journey of semiconductors began decades ago with the invention of the transistor. Over time, microchips have become smaller, faster, and more efficient, following Moore's law, which predicts the doubling of transistors on a chip every 2 years. This rapid advancement has led to the explosion of digital devices and the rise of smart technology. Today, microchips are at the heart of everything from artificial intelligence to autonomous vehicles. Let's now dive into the structure of a semiconductor chip. Semiconductor chip is a marvel of engineering. It consists of millions, sometimes billions, of tiny transistors etched onto a wafer of silicon. These transistors act as switches, turning electrical signals on and off to process information. The complexity of these chips allows for incredible computing power in a compact space. As we move forward, we'll explore the materials used in making these chips and why silicon is so popular. Silicon is the preferred material for semiconductors because of its abundance, stability, and excellent electrical properties. It can be purified and shaped into wafers with extreme precision, making it ideal for mass production. Silicon's unique characteristics allow for the creation of integrated circuits that are both reliable and cost-effective. Next, let's look at the process of manufacturing semiconductor chips. Manufacturing a semiconductor chip is a highly complex and precise process. It starts with the creation of a pure silicon wafer, followed by photolithography, doping, etching, and layering to build intricate circuits. Each step requires cleanroom environments and advanced machinery to ensure accuracy. The result is a tiny chip packed with immense computing power. Now, let's examine the role of transistors in these chips. Transistors are the fundamental building blocks of semiconductor chips. Acting as tiny switches, they control the flow of electrical current, enabling logic operations and data storage. Billions of transistors can be found on a single chip, working together to perform complex calculations at lightning speed. The miniaturization of transistors has been key to the advancement of modern electronics. Let's move on to integrated circuits and their significance. Integrated circuits, or ICs, are assemblies of multiple electronic components, like transistors, resistors, and capacitors on a single chip. This integration allows for greater functionality, reduced size, and lower cost. ICs are found in virtually every electronic device from calculators to supercomputers. Their invention marked a turning point in the history of technology, paving the way for the digital revolution. Next, we'll look at the different types of semiconductor devices. Semiconductor devices come in many forms, including diodes, transistors, and integrated circuits. Each type serves a specific purpose in electronic circuits, from rectifying current to amplifying signals and processing data. The versatility of semiconductor devices has enabled the development of a wide range of technologies, from simple gadgets to complex computing systems. Now, let's explore the applications of semiconductors in various industries. Consumer electronics like smartphones, tablets, and laptops rely heavily on semiconductors for their operation. These chips enable high-speed processing, connectivity, and advanced features such as touchscreens and cameras. The demand for smarter, faster, and more efficient devices continues to drive innovation in the semiconductor industry. Next, let's see how semiconductors are used in the automotive sector. Modern vehicles are equipped with a wide array of semiconductor devices. From engine control units to advanced driver assistance systems, semiconductors ensure safety, efficiency, and connectivity on the road. Electric vehicles in particular depend on sophisticated chips for battery management and power control. As cars become smarter and more autonomous, the role of semiconductors will only grow. Let's now look at semiconductors in industrial automation. Factories and production lines, semiconductors play a crucial role in automation and control systems. They power sensors, actuators, and programmable logic controllers, enabling precise and efficient manufacturing processes. The integration of semiconductors in industrial equipment has led to increased productivity and reduced downtime. As we move forward, let's discuss the importance of semiconductors in healthcare technology. Semiconductors have transformed healthcare by enabling advanced diagnostic and monitoring equipment. Devices like MRI machines, pacemakers, and wearable health trackers all rely on semiconductor technology for accurate data processing and real-time monitoring. These innovations have improved patient outcomes and made healthcare more accessible. Next, let's explore the use of semiconductors in telecommunications. The telecommunications industry has been revolutionized by semiconductors. Chips enable high-speed data transmission, signal processing, and network connectivity, forming the backbone of the internet and mobile communications. From 5G networks to fiber optics, semiconductors make global communication faster and more reliable. As we continue, let's look at the challenges faced by the semiconductor industry. Despite their importance, the semiconductor industry faces significant challenges. These include supply chain disruptions, increasing complexity, and the need for constant innovation. The global chip shortage has highlighted the vulnerability of the industry to external shocks. Companies are investing heavily in research and development to overcome these hurdles and meet the growing demand for advanced chips. Next, let's discuss the environmental impact of semiconductor manufacturing. Semiconductor manufacturing is resource-intensive, requiring large amounts of water, energy, and chemicals. The industry is working to reduce its environmental footprint by adopting greener processes and recycling materials. Sustainable manufacturing practices are becoming increasingly important as society demands more eco-friendly technology. Let's now look at the future trends in semiconductor technology. Future of semiconductors is bright, with emerging technologies like quantum computing, artificial intelligence, and the Internet of Things driving innovation. Chips are becoming smaller, faster, and more energy efficient, opening up new possibilities for smart devices and connected systems. As we look ahead, the semiconductor industry will continue to play a pivotal role in shaping the digital landscape. Next, let's explore the concept of Moore's Law in more detail. Moore's Law, named after Intel co-founder Gordon Moore, observes that the number of transistors on a chip doubles approximately every 2 years. This trend has driven exponential growth in computing power while reducing costs. However, as chips approach physical limits, maintaining this pace becomes more challenging. Researchers are exploring new materials and architectures to keep up with demand. Let's now look at alternative semiconductor material. As silicon approaches its physical limits, researchers are turning to new materials like gallium nitride, graphene, and carbon nanotubes. These materials offer superior electrical properties and could enable faster, more efficient chips. The adoption of new materials could revolutionize the industry, leading to breakthroughs in computing and communications. Next, let's discuss the importance of semiconductor design. Designing a semiconductor chip is a complex process that involves balancing performance, power consumption, and cost. Engineers use sophisticated software tools to create and simulate chip layouts before manufacturing. Good design is crucial for ensuring reliability and efficiency in electronic devices. As we move forward, let's look at the role of foundries in the semiconductor supply chain. Foundries are specialized manufacturing facilities that produce semiconductor chips designed by other companies. Major foundries like TSMC and Global Foundries play a critical role in the global supply chain, enabling fabless companies to bring their designs to life. The foundry model has accelerated innovation and allowed for greater specialization in the industry. Next, let's discuss the concept of fabless semiconductor companies. Fabless semiconductor companies focus on designing chips while outsourcing manufacturing to foundries. This business model allows them to concentrate on innovation and reduce capital expenditure. Companies like Qualcomm and NVIDIA have thrived using this approach, driving rapid advancements in chip technology. Let's now look at the importance of testing and quality control in chip production. Quality control is essential in semiconductor manufacturing. Each chip undergoes rigorous testing to ensure it meets performance and reliability standards. Defective chips are identified and discarded, while only the best make it to market. This process guarantees that electronic devices function as intended and remain safe for consumers. Next, let's explore the global distribution of semiconductor manufacturing. Semiconductor manufacturing is concentrated in a few key regions, including East Asia, the United States, and parts of Europe. Countries like Taiwan, South Korea, and the US lead in chip production and innovation. This global distribution ensures a diverse and resilient supply chain but also introduces geopolitical risks. Let's now discuss the impact of geopolitics on the semiconductor industry. Semiconductor industry is deeply affected by global politics. Trade tensions, export controls, and national security concerns can disrupt supply chains and impact innovation. Governments are investing in domestic chip production to reduce dependence on foreign suppliers. As the world becomes more digital, the strategic importance of semiconductors will only increase. Next, let's look at the role of research and development. Continuous research and development are vital for the semiconductor industry. Companies invest billions in R&D to discover new materials, improve manufacturing processes, and develop next-generation chips. Collaboration between industry, academia, and government accelerates innovation and keeps the industry competitive. Let's now discuss the importance of intellectual property in semiconductors. Intellectual property, IP, is a cornerstone of the semiconductor industry. Patents protect innovative designs and processes, ensuring companies can recoup their investments. IP disputes can be costly and impact the pace of innovation. Strong IP protection encourages creativity and competition, benefiting the entire industry. Next, let's look at the role of software in semiconductor design. Advanced software tools are essential for designing and simulating semiconductor chips. Electronic design automation, EDA software helps engineers create complex layouts, test performance, and optimize designs before manufacturing. The integration of software and hardware is key to developing efficient and reliable chips. As we continue, let's discuss the importance of education and workforce development in the industry. Skilled workforce is essential for the growth of the semiconductor industry. Universities and technical schools offer specialized programs in electronics, materials science, and chip design. Ongoing training and professional development ensure that engineers stay up to date with the latest technologies. Investing in education helps maintain a competitive edge and drives future innovation. Next, let's look at the role of government policy. Government policies play a significant role in shaping the semiconductor industry. Funding for research, tax incentives, and infrastructure investments help companies innovate and expand. Strategic partnerships between government and industry can accelerate technological advancements and strengthen national security. As we move forward, let's discuss the impact of semiconductors on the global economy. Semiconductors are a driving force behind the global economy. They enable the growth of industries like electronics, automotive, healthcare, and telecommunications. The value chain includes raw material suppliers, manufacturers, designers, and end users, creating millions of jobs worldwide. The industry's growth fuels innovation and economic development across the globe. Next, let's look at the challenges of supply chain management. Managing the semiconductor supply chain is a complex task involving multiple stakeholders across the globe. Disruptions can have far-reaching effects, as seen during the recent chip shortages. Companies are adopting strategies like diversification and local sourcing to mitigate risks. Effective supply chain management ensures timely delivery of chips and supports industry growth. Let's now discuss the importance of security in semiconductor devices. Security is a top priority in semiconductor design and manufacturing. Chips must be protected against hacking, counterfeiting, and intellectual property theft. Hardware-based security features are integrated into chips to safeguard sensitive data and ensure device integrity. As digital threats evolve, the industry continues to enhance security measures. Next, let's look at the role of semiconductors in emerging technologies. Artificial intelligence, AI, relies on powerful semiconductor chips to process vast amounts of data quickly and efficiently. Specialized AI chips such as GPUs and TPUs are designed to handle complex computations required for machine learning and deep learning. The synergy between AI and semiconductors is driving breakthroughs in fields like healthcare, finance, and autonomous vehicles. Let's now explore the impact of semiconductors on the Internet of Things. Internet of Things connects billions of devices worldwide, from smart home gadgets to industrial sensors. Semiconductors provide the processing power and connectivity needed for these devices to communicate and share data. As IoT expands, the demand for energy-efficient and secure chips continues to grow. Next, let's look at the role of semiconductors in renewable energy. Renewable energy systems such as solar panels and wind turbines rely on semiconductor devices for power conversion and management. Chips help optimize energy production, storage, and distribution, making renewable energy more efficient and reliable. The transition to clean energy is creating new opportunities for semiconductor innovation. Let's now discuss the importance of miniaturization. Miniaturization has been a driving force in the semiconductor industry. Smaller chips mean more power and less space, enabling the creation of compact and portable devices. This trend has transformed everything from mobile phones to wearable technology. As chips continue to shrink, new challenges and opportunities arise for designers and manufacturers. Next, let's look at the role of packaging in chip performance. Chip packaging protects semiconductor devices and affects their performance, heat dissipation, and connectivity. Advanced packaging techniques such as 3D stacking and system-in-package allow for greater integration and efficiency. Packaging innovations are essential for meeting the demands of high-performance computing and mobile devices. As we approach the end, let's summarize the key takeaways from our journey. Semiconductors are the foundation of modern technology, enabling advancements in computing, communication, healthcare, and energy. Their unique properties and versatility have transformed the way we live and work. The industry faces challenges but continues to innovate, driving progress in every sector. As we look to the future, semiconductors will remain at the heart of technological evolution. Thank you for joining us on this exploration of the semiconductor world. As we move forward, the semiconductor industry will continue to shape the future of technology. Emerging trends like quantum computing, AI, and IoT will drive new innovations and applications. Collaboration, research, and investment will be key to overcoming challenges and unlocking the full potential of semiconductors. Stay curious and keep exploring the incredible world of microchips. Thank you for watching this deep dive into the world of semiconductors. We hope you've gained a better understanding of how these tiny components power our digital lives and drive innovation across industries. The story of semiconductors is ongoing, and the next chapter promises even more exciting breakthroughs. Until next time, keep learning and stay inspired by the wonders of technology. Let's quickly review some key terms from our journey. Semiconductor, a material with connectivity between a conductor and an insulator. Transistor, the basic building block of chips acting as a switch. Integrated circuit, multiple components on a single chip. Foundry, a facility that manufactures chips for other companies. Fabless, companies that design but do not manufacture chips. These terms are essential for understanding the semiconductor industry. If you're interested in learning more about semiconductors, there are plenty of resources available. Books, online courses, and industry reports offer in-depth knowledge on chip design, manufacturing, and applications. Staying informed will help you appreciate the ongoing innovations and the impact of semiconductors on our world. Thank you again for joining us and happy exploring. This concludes our video on the secrets of semiconductors. We appreciate your time and curiosity. Remember, the world of technology is always evolving and semiconductors are at the heart of it all. Stay tuned for more insightful content on science and innovation. Wishing you a future full of discovery and technological wonder.